How are you guys doing? How many of you came to the keynote today? All right, almost all of you, great. This is good advertising, I guess, if you plug your talk in the keynote.
You should do it more often.
Yeah, we should ask Scott to put us in the keynote every time.
Well, welcome, guys, to our session. I think it's about time, so we should probably begin. My name is Kirill Gavriluk, and with me is the star of the day, Yavor. And we are both from Microsoft Azure mobile team. The old names die hard. Microsoft Azure mobile team. And today we're going to talk about mobile services, elaborate from the themes that you've seen in the keynote, and drill more into the different capabilities and scenarios that mobile services enables. Specifically, we're going to talk about mobile services.NET Flavor, the new programming model to extend your mobile service with custom code in the backend. How many of you are familiar with mobile services? All right, good. So we'll assume some basic familiarity, but even if you haven't used mobile services or haven't seen it, you'll be able to follow along. After all, the whole purpose of mobile services is to make things easy. So we're going to go over a variety of functionalities that Yavor earlier demoed in the keynote in more detail. We're going to look at data access offline. We're going to look at the authentication. We're going to pay especially attention to the scenarios around employee-facing apps. However, to start from the start, mobile services is great for both consumer and employee-facing apps. The whole goal, the entire goal of bringing .NET to mobile services was to enable you guys, to enable broader audience to easily add backend to their mobile clients, and at the same time use the familiar technologies, familiar APIs, familiar tools. Mobile services is good for both consumer and employee-facing apps, and we're going to show you how .NET, while preserving the simplicity promise of mobile services, extends the capabilities, extends the power that you can achieve in the backend. Throughout the talk, we're going to drill into the capabilities using the following scenario as an example. Let me switch to an actual app. This is your cable guy's dashboard. So everyone is familiar with cable guys. So they typically come with a tablet to your house, and they fix things, and things start working. And they need an app that gives them right in front of at their fingertips, gives them an overview of all their jobs scheduled for this day, all the history for this particular customer, what went wrong, what do they need to bring from the stock with them, what parts, what didn't work before. All right. As you can see from this app, as a cable guy, I need to be able to authenticate to get access to this data. So I need to be able to authenticate using my corporate credentials. I need to be able to work with data. It's hierarchical data. I need to be able to work with the data not only when I'm connected to the network, but also when I'm not connected. As I visit some places, I don't know about San Francisco, but certainly in Seattle, there are many places where you don't get connectivity. And so you should be able to work with data. You should be able to add updates, additions, and yet when the app is back connected, being able to sync those changes back to the backend. Of course, sometimes I might schedule changes. New customers request my attention. Some customers cancel appointments. As a cable guy, I would love if the app would notify me about the changes in my schedule, as opposed to me going and clicking refresh button. So we also will show you how to leverage push notifications for these scenarios. So all of these, it's a great example to illustrate the capabilities of mobile services. And with that, over to Yavor, who's going to show you a lot more about them.
Thank you. So we'll start with going over a lap of the .NET backend. So start with what you saw in the keynote today and kind of build on that and show it in a little bit more detail. So let's start in Visual Studio. As you saw today, we have our project template right here on the you can get to it under the Cloud node, or you can also get to it from the one ASP.NET dialog. So we're based on ASP.NET Web API, so it's easy to get to it from both places. And then, of course, I'm not going to go through that. You've all seen how project template works, so I have it instantiated right here. And we can just walk through the important components. You also are to-do item, which is, almost every mobile service starts with some sort of to-do list. If you get our quick start from the portal, there's a to-do list, so you've seen plenty of that. But the interesting thing I want to highlight here is this base class. So when you're building a .NET mobile service, you start with a base class, and in this case, it's entity data. And the role of that base class is it contains all the properties you need for things to work correctly. If you don't want the class, you don't have to have it, but it definitely helps. So you always need an ID. And then if you want to take advantage of the offline features we're about to show after, you need some of these other properties, including created at, deleted, version. So these are things that the mobile services backend uses for optimistic concurrency support, so that we know when there's certain conflicts, and we'll show you a little bit of that later. But all you need to know for now is, as long as you have a class that inherits from entity data, it will work great. And if you don't want entity data, you can drop that, and that'll also work. Now, the next step, of course, is to add a controller. And we didn't go into detail in the keynote, but I'll walk through it now a little bit more. So we have this initialize method on our controller, and you inherit from table controller, and that's always going to be the case, right? For any kind of mobile service, regardless of what kind of backend you want to use, you're always going to inherit from table controller. And in this case, we specify our to-do item. You're going to have an initialize method, and the role of the initialize method is to instantiate a domain manager. The domain manager is basically a wrapper over a given data store. So that's the other abstraction you need to learn. So you need to learn, table controller and domain manager, and that's pretty much all you need to know. Everything else is just web API primitives. And in this case, we're going to use Entity Framework backed by a SQL database. So we have an entity domain manager that we provide. And you don't need to learn the details of it. You just plug it in, and then it will work just great for an entity framework. If we want to bring in a different backend, as you'll see further on in the talk, we have different domain managers for the different providers we support. So we can bring in Mongo, we can bring in Azure Table Storage, just by swapping out the domain manager. And that's kind of the key point here, is that your table controller, the logic stays pretty much stable across the different backends. All you need to do is just swap out this domain manager. So the rest of it is, kind of the vanilla CRUD methods the Web API already has. I have a get all, returns all the items. I can do a get on an individual item. Then I have patch, post, delete. That's pretty much standard Web API stuff. So kind of CRUD operations on top of this collection. Great. So we talked about the controller that's already there in my project, but what if I want to add a new controller? We have integration right here in the scaffolding dialog. And so I can go through and add a table controller, as you saw today. What I want to highlight now is actually this other option here, which is a custom controller. And this is very simple, so we can call it the build controller. And what this will generate is actually just a regular API controller. And this is an important point to make. So an API controller is not something that our team came up with. This is something that's just a web API concept. It's basically the base class that all web API controllers inherit from. And what that means to you as a developer is that you can easily take existing web API code that you already have and bring it to mobile services. So we didn't actually have to have this template. It's just there for discoverability. Really, everything here is just web API. And by default, it's very simple. It just says hello, and we'll go through that later. So let's go ahead and hit F5. And I've already set a breakpoint in here. So we have our friendly landing page, which will come up. And this may be a little bit slow because I've turned on symbols, so I can show you debugging later. So it takes a few seconds to pop up, but when it does, there it is. You can try it out. Now, if you're a web API developer, this part here might be pretty familiar. This is a documentation page. That's actually a component that you can reuse from web API. And then if we go inside of our get method here, we have our test client, right? And the test client is basically a mini HTTP request generator right in the browser, like a mini fiddler. And you can just, you can specify headers if you'd like. And you can specify a body if it's not a GET request, but in this case, it's just a simple GET. Go ahead and send that, and we hit a breakpoint in our server code. Pretty much you all saw that in the keynote, and then if we resume, we'll see our results back in the browser. And the JSON format you see here, that's key, right? That's kind of the main value proposition of the table controller, is that it returns this JSON format that all of our different clients understand. Our Android client, our iOS client, our Windows clients, they all know what to do with this JSON, and that's the main value you get from that controller, sort of a consistent programming model across devices. Okay, so we've done the simple local run through. Now let's actually go and publish to the cloud, as you saw in the keynote this morning. Go ahead and pick mobile services here. I'm already signed in with my Azure account, so I'll pick an existing service that I created previously. I could create a new one. It just takes about 20 seconds, and I don't want to waste your time, so let's just pick this one right here. Now, there's an important thing we skipped in the keynote, and I want to draw your attention to it, which is this next screen here. You're given the choice of different build configurations, and by default, it's going to deploy a release build, which is nice because it runs fast, but if you want to really be able to debug your service, you really probably want to pick the debug build. So I'll go with that, and then press publish. And this uses web deploy to send my files to mobile services. And if everything goes well, it should just pop up. Now, the next bit is we have our service deployed in the cloud. Now, we want to try the same stuff we were trying locally. We want to try the test client. So let's try and do that. I'll actually do it in private tab. And I'll try to go to my help page. But what you'll see here is actually it's prompting me for a username and password. And this is important. When I'm doing local development, we basically let through all the traffic because we don't want to get in your way. So if you're testing your Windows app locally and your backend locally, we don't want to get in your way and ask you to give us to authenticate. But when you deploy to the cloud, our default is actually to be secure because we want to make sure you don't accidentally publish a service and reveal stuff you didn't mean to. So what are the username and the password? Well, mobile services already has this idea of an application key, which is something that only your client app knows. And if you go to the Azure portal, you see I have the app I just created. I can just copy the key, and I can just paste it in right here. And we take a blank username, you just pass the key as a password, and it should let me through to that documentation page you saw earlier. Okay, so now I'm authenticated. Now I can use this in the cloud. So I can do that same trick, go through and send a little HTTP GET, but I'm not going to bore you with it. Let's move straight to how do I debug this now that it's an instance running in the cloud. And you can tell it's in the cloud because it's no longer localhost. It's actually now running on AzureMobile.net. So how do I set myself up for debugging? Well, the first thing I need to do is in my Visual Studio instance, we want to make sure we have all the symbols downloaded because in order to have meaningful debugging for the .NET backend, you really want to probably have the symbols. So if I just go right here, you'll notice I've added an extra symbol source, which is this one here. And symbolsource.org is a place where a lot of NuGet packages can very easily upload their symbols, and that's what we've done. Our runtime is a NuGet package, so we just uploaded our symbols, and this just works seamlessly. All you need to do is just add this source to Visual Studio, and the rest will work just fine. So I've done that. And then I published with the debug build. So then my next step is to just head over to Server Explorer. And this may be a little bit small to see, but we actually have great integration for mobile services right here. And all the services I have are listed. So let's find the one we published to, and I think we called it Build Demo 2. I can just right-click and say Attach Debugger. And depending on the connection and which way the wind is blowing, this can take a few minutes sometimes. But here it is. So now I'm actually attached. You can actually look at my Visual Studio instance, and you can tell that it's actually, maybe you can't tell because it's small, but you can see it's locked to the W3 WP process. That's the web server that's running on the VM. OK, so I'm attached. I have my breakpoint. Let's go ahead and send it a request. And we use that same test client that we used before. And there we go. Now we've hit a breakpoint in our cloud instance. You don't have to clap this time. In the keynote, I was really fishing for it, but it's OK. All right, so the interesting thing here, though, is I need to prove it to you that you're actually in the cloud, right? What do you actually get? So if I take a look at my locals window here, actually, you know what? I think I have a, I think I already set a watch on the variable I want to show you. If VS will cooperate. But basically what I mean to show you here is that we now have access to basically a very, let's try it again. That's not cooperating, but basically we have access to all the server variables that are injected into our environment. We have effectively a different version of the runtime actually hosting your service in the cloud, and it's bootstrapped with a different set of settings. There's a different connection string. There's a notification hub connection string for push notifications. We have all the settings you may have configured in the portal, and all that gets injected into your service. So it's kind of an easy way to tell whether you're local or remote. You can just look at the set of settings, and you'll see kind of real life connection strings being populated when you're running in the cloud. Yeah, that's strange. The VS had this hiccup, but all right. So we got. We should get our results back in the browser as usual. So kind of in summary, local development, local debugging, and then deploying to the cloud, and then hitting a breakpoint and debugging live on the VM in the cloud. Great. So that's what we have for our that's what we have for our lap around. Now, I wanted to drill down into. I can find the little clicker. Do you have it? Oh, there it is. That's our lap around. Kind of some of the simple cases straight from the template. Now, we want to talk about some more advanced cases, and so to do that, let's kind of introduce some of the principles we had in mind when we designed this in the first place. Obviously, number one, don't reinvent the wheel. We built on top of Web API. Don't scare away client developers. We're still primarily targeting client devs here. So whenever Web API did something that wasn't quite discoverable or that we could do in a better way or a cleaner way, we actually have wrapped that. The old Web API way is still there, but in some cases we've made simplifications. We have this big focus on enablement, which means you can bring any NuGet package. You can use any data store. We really want to make sure it's kind of as open as possible for you to extend. And this makes sense in the case of .NET because a lot of you have existing assets you want to bring over. Visual Studio is key. We realize most of you live and breathe in VS, and so that's the tool we really wanted to first class for you. We want to deliver differentiated value, and I'll show you later what I mean when I say that. But when you publish to mobile services, you do get a bunch of extra value than if you were to just publish to your own server or something like that. And then when we talk about .NET, sometimes people ask, well, what's happening to Node.js, right? The fact that we're introducing .NET doesn't mean the Node.js story is going away. In fact, we're going to keep both stories and keep evolving them side by side. We love them both equally. And then the last point is kind of something I already demonstrated, but our existing clients will continue to work. The wire formats are the same between Node and .NET. So everything, all the existing client investments with mobile services will continue to work. So here's some of kind of the more detailed breakdown of scenarios we've enabled. Web API, as far as data stores, we have Azure databases. You can do an on-premise SQL server, as you're going to see later, table storage, MongoDB. I'll talk about the AutoMapper point later. When it comes to authentication, we support all the social providers that mobile services is known for. And to cater more to this enterprise scenario that Kirill introduced in the beginning, we do have support for Active Directory as well. And then push notifications are now powered by notification hubs. So if you're familiar with that, it's a scalable push engine in Azure. Mobile services in the olden days had its sort of manual push notification engine built in, but we switched to this much more scalable solution now that works much better, to be honest. And then as far as tooling, our runtime is available on NuGet. We've integrated the test client that you just saw. And we've really spent a lot of time with VS. We have local F5, we have IntelliSense, we have web deploy and integration with the publishing experience, and then remote debugging, which are some of the things I showed earlier. Now, when we look into the future, there's certain things we didn't get to for building, and we definitely want to continue investing in. So we do want to bring additional data stores. We saw SharePoint on stage today, but we don't really treat SharePoint as a data store. We kind of treated it as an external service to integrate with. I think there's more work we can do to treat SharePoint as a first-class data store. We want to introduce in-app messaging scenarios, such as, for example, if you want to have not just a sort of push notification, but actual bidirectional channel between your app and the backend using technologies such as SignalR. So that's another thing we're looking to do. Integration with BizTalk for enterprise scenarios, that's yet another thing we want to do sort of in the data space. So a lot of work on our roadmap going forward. I'm sorry? I think BizTalk services will be first. Yeah. Then when it comes to authentication, we support currently the server flows, but if you want to use the native device SDKs for Facebook and things like that, then what you care about are these client flows, and that's something that's on our roadmap for the next couple of months as well. And then tooling, we've tooled a lot of scenarios currently around Git, and we do plan to bring TFS into the fold as well. Great. Oh, so I did that out of order. That's fine. We saw publishing. So when we published, I mentioned that we actually provide a sort of differentiated hosting environment. And I want to elaborate a little bit more on what that actually means. If you look at sort of the left part of the slide, and you think of Azure websites, that's sort of the normal websites publishing flow. You can publish a bunch of binaries via web deploy, or you can check in a bunch of source code via Git and then have our sort of server infrastructure do the build for you and then deploy the binaries. Ultimately, you end up with binaries in a folder somewhere, and that's how a website would work. Now, mobile services does something slightly differently, which is it actually will run from a completely different location, and it will look inside the folder where you deploy the binaries, and it will start pulling all your controllers and all your types from there. And the benefit of this approach is that we can actually service the runtime without you having to redeploy. So kind of the thing that you're seeing at the bottom of the screen there, if there's that's kind of our framework, and it's built on top of Web API and all these community NuGet packages. But if there's a bug in one of the packages, we can actually service that and refresh it in place without you having to redeploy. Another benefit of running off of this runtime is we have much better instrumentation. We actually have analytics data flowing to our team constantly about the service that you run. And we can use that to troubleshoot problems with your service and let you know if something goes wrong. And then the third sort of major benefit is that we can bootstrap some things that are unique to the cloud. So we give you a free notification hub with every mobile service. We just inject that string for you. Of course, we inject the SQL connection string for you. And you can see many other integrations that we can similarly just power up in the cloud. So when you go to the cloud, things are already pre-wired for you. So we talked through sort of the next level of detail across our feature set. And now we're going to go basically drill into data, and then Kirill's going to drill into auth and push. So let's talk about data. Let's talk about sort of the simple scenario first, and we call this greenfield. And that means you're starting a brand new app with the cloud today. We have the table controller, which you saw, and then the domain manager, which I introduced earlier. And these are kind of the two things you need to know about. And then there's the varieties of different backends you may want to support. And there's one different domain, that should be called domain manager. The domain manager, there's a different one per backend, right? So for SQL, it's called the entity domain manager, and then we have a Mongo domain manager, et cetera. So that's how you build sort of a simple application. Now, the key thing to realize here is there's only one type. There's only one model. And I've called it the DTO in this slide, or the data transfer object. It's the same type in the database, and it's the same type on the client. And it just flows through the mobile service. So that's the simple case. The more complicated case, which is the case you guys probably care about, is the case where you're bringing existing assets to the table, and you're trying to build a mobile solution around that. So let's try and read this from your right. So you have an existing database either in Azure or locally, and it has a bunch of existing tables. Now, what does it take to get that to work? Oh, and you probably also have an existing model, so you see that over there. So what does it take to get those things to work with mobile services? Well, if you look at the service, you have a domain manager, and we have a special case here. It's called a mapped entity domain manager that lets you sort of do the mapping between the data transfer object and your model. And the table controller stays the same. Right, so we kind of introduced this idea of two types. One type that goes back and forth between the service and the client, the data transfer object, and then your existing model and your existing database. And the goal here is for your model and your database to stay largely unchanged, because we recognize that this database could be used by other services you have running, by other applications, and we don't want to disturb that. So we'll go into a little bit more detail here. And the last thing we want to talk about sort of in this data space is support for offline. And offline clearly means that if I bring my device to a place where I don't have any connectivity, I can sync down some data, work with it locally, and I'm still not connected. And then when I go back to the office, I can reconnect and sync up the data. And you'll see how that's built into the table controller. And it does work with all different backend choices as well, which is pretty cool. So we'll go through all these cases in a code demo, but I just wanted to kind of set the stage for you guys for a minute. So let's jump back into Visual Studio. And I'll actually switch to a different project here. And we'll start with MongoDB first. So let's say I want to use a different backend. For some reason, I prefer document store. I don't like to use a relational database such as SQL. So I want to use MongoDB, right? And so let's go ahead and show how to do something like this. I have a type here, and it's called a Mongo to-do item. And it's very similar to our original to-do item, except you'll notice it has a different base class. Instead of entity data, it has document data. And if we drill into document data, you probably can guess what this is, but it has similar properties, but they're just a little bit different. First, if you look at the ID, if I can find it, it's actually like a slightly different ID. It's not the same ID that SQL has. Mongo's ID is a 24-character hex string. And in SQL, it could be something else. So it's kind of specific to a document-style store. And then the other properties are also slightly different. But basically, it's a base class that's tailored to the data store you're about to use. Then we go to the actual controller. So you'll notice I have a Mongo to-do item controller. And like I promised you, all my CRUD methods here look largely the same, with the one difference being that we have a different domain manager. And so we have a Mongo domain manager that we ship in the box, and it just knows how to talk to Mongo. It knows how to work with these models that inherit from document data. And I've specified my connection string right here. So it's that simple, really, to switch between a SQL backend and a Mongo backend. And we can go ahead and try this out. Now, I need a Mongo database for this, right? So this is a great opportunity to actually plug an awesome feature of the Azure portal. So I need a Mongo database. It's a pain to download it locally. But if I go to the Azure store, I can actually just find right here, I can find our friends from Mongo Labs. If I scroll down, or is it under, I don't know exactly where it is, but under the letter M, I have Mongo Labs. And they're great. They basically give me a free database somewhere up in the cloud, so I don't have to set up MongoDB locally, which is great. And I already did that, and it's costing me $0 right now until I reach some certain size. And I can actually just head straight to the Mongo Labs portal from here. And I'm signed in. I have a single billing relationship. I didn't have to create an account. It's great. So here's my Mongo Labs database, and then I have 0 documents. I don't know if you can see that well, but basically I have my collection. It's called to-do items, and I have none of them in there. To our service project. And we'll run this in the browser. Now, I've added a few controllers here, so you'll see a slightly different documentation page. It has my Mongo controller you just saw. So we'll go and actually create an item right in the browser. And now everything I'm showing you here that I'm doing in the browser, you could do from the client as well, using the client SDKs, as you'll see in a minute. So let's find our Mongo controller right here. So Mongo to do item. And we'll actually create a new item in there. So I'll send a HTTP post, which is the way you tell things to create in the world of HTTP. So try it out. And then some useful information here about what the potential things are. Let's think of something clever here. Come to my talk. We have one tomorrow also. OK, and we'll set this to false. And I'll go ahead and hit send. And this will go off, call the Mongo database, living in Mongo labs. And you notice I get a created status, which is good. That means everything went well. And it's returning me the information from MongoDB. And this is that funky 24-character hex string that I mentioned is the ID. But you see kind of some of the specifics of the provider coming through a little bit here. And then, just to prove to you, we can head back to the Mongo Labs page here. And we have one document inside of our collection. And here's our item we just added. So in summary, in this case, we played that we prefer a document store instead of a SQL store. We went ahead and wrote a different model class. We barely changed our controller. We just literally swapped out the domain manager to a Mongo domain manager and republished, and that's it, basically. It's that easy to consume MongoDB. Now, the next thing I wanted to show you is kind of, so this was like a greenfield case. Like this is mapping to that first slide, a new app just with a different data provider. Now I want to talk about the next case, which is the brownfield, bringing my existing assets to mobile services. And for that, actually, I'll start in my Server Explorer. And I realize this is small. You notice I have two tables here. I have jobs and customers. And let's say that's my existing data that I have on-premise that I can't mess with. This is a schema that has to stay. I can't modify it. And I can show you what it is. So these are the jobs. And you can map this back to Kirill's example, right? This is the jobs that the cable guy has to do. So he has to install a new TV, replace one. But we have basically this schema that we can't change. And you notice every customer has every job has a relationship to a customer. And I can show you that table as well. We have, I think, 3 customers, and each customer has an ID. So this is an existing database, an existing schema that we can't change. So how do we integrate that with our mobile service? Well, let's look at the code here. So this is our existing class, right? This is the job, and that's the class that we use to create that schema. And the job has a relationship to a customer, right? And that's an entity framework thing. It's a navigation property. So entity framework knows how to do that join and pull up the customer from the other table. So this is a rather complicated model, to be honest. That's not something that a lot of these clients will understand. That's not something that's easy to model in a client app. So it's an example of a complicated server model that we want to simplify when we send over. So here's the job class, and here's the customer class, right? And the customer has a collection of jobs. And Entity Framework is very smart about this. It knows how to handle these relationships. But our clients don't. So how do we create those data transfer objects, right? How do we go from the model to the DTO? You'll notice I have 2 classes here that I've created. I have a mobile customer, and I have a mobile job. And they look very close to the customer in the job class, but they have those complicated relationships stripped out. So the mobile job has, all the useful things that the job had, like a description, quantity, etc. But it doesn't have that link back to the customer that we can't serialize. And then if you look back at the customer, it's similar, right? So the customer just has the ID and the name, but it doesn't have the collection of jobs, right? So we've kind of filtered out the things that we know you can't serialize and you can't handle. So how does the backend know to map between these types? We use a community piece called AutoMapper, which is actually really, really good at this stuff. So if we head over to our Web API config here, this is where all the config magic happens. You notice we've defined this mapping, right? And this is AutoMapper. But we basically say, when you're about to talk to the database and you receive a mobile customer, the database is going to expect a customer, right? So this is how you go from one to the other. So we basically define the relationship one way, or we define it the other way. And this is not mobile services specific, right? This is just how you use AutoMapper in general. But this is nice because it does that transformation for us. So the client will only see the mobile customer, and the database will see the customer, and there's a clean mapping between the two. Great. So now that we've seen that, we can actually go ahead and run this project. You can hit F5. And what we should see, right? We shouldn't see those model entities flow through, like the customer and the job. We should see the ones we projected, right? We should see the mobile order and the mobile customer, or the mobile job and the mobile customer. So here it is. Let's say mobile job. We can do a get, and you should see basically those projected types. Right? So there we go. Maybe it's a bit small. Right. So we've transformed this really complicated entity framework model into something simple that our clients can now understand. And so far, I haven't shown you any actual client code, right? We've been doing everything with JSON and using our test client. So maybe you think I'm lying to you, the clients actually work. So I thought, wouldn't it be challenging to actually take an existing model and add offline to it, right? Instead of picking a simple model like a to-do item, I said, let's go nuts here, right? Let's take the existing model and build offline. And the reason why that works is because we're simplifying the types, right? We're basically projecting to something that's pretty simple. It's this clean, nice JSON, and the offline framework that we built works the same, whether it's an existing model or a brand new one, whether it's Mongo, whether it's whatever, what have you. It'll still work the same way. So to show offline, let's hop over to an app that we've built previously here. Let me close down some of these. Right. So this is a version of Carol's Field Engineer app. Except we've simplified it, right? Because I didn't want to have to model all the different things that app has. So this is just a constrained set that just has customers and it just has orders. So you'll notice right now I don't actually have anything, right? Because think about this. This is an offline app. So the first thing I need to tell it is, well, go download the stuff, right? So I don't have any customers here. I can't create a new job because I don't have any customer to associate with. So I'll go ahead and hit the sync button, and this will do that first call and bring back the customers and jobs we had on the server. So this is that same data you saw in the service. I replaced faulty TV, new customer installation, etc. So let's go ahead and now pretend we're offline. So I'm going to rip the laptop off and tear away the network, and now we're in a field somewhere. Let's go ahead and submit a new request here. Let's see, fix broken cable. We can go ahead and correct something here. So let's say fix is done, and we press save. So now from our app's perspective, I could close this and relaunch it, and you still see those changes, right? So this is basically to show you that the data is now stored locally. And we use SQLite to store the database on the device, and this is nice because it works across a variety of devices. So this is now safely stored on my device, but let's look at the back-end data. So I'll actually just switch back to Visual Studio. And we'll find those tables we were looking at. And so what is this? This is jobs, right? I edited a bunch of jobs. If we view the data here, you'll see it's unchanged. right? So then let's go back to the app now. And we'll press the sync button. So this is when we've reestablished connectivity. And we can do this easily by just listening to the operating system events about whether the network is available or not. We can trigger a sync. And I'll just do this manually here. So there's a little bit of a flicker, and we can now check back with our backend here, do a little refresh on this table. And you notice the entities are now updated. Great, so offline. Let me show you the actual code I had to write in the client app to get this working. It's actually really simple. We have a new primitive in our client SDK, and it's called the Mobile Services Sync Table. And we wanted to kind of be explicit about the fact whether you're working with an online table, and that's called a mobile service table, or an offline table, a mobile service sync table. So that's kind of the primitive you will work with when you're doing offline. The first thing you need to do is make sure that the local DB instance is initialized. So we have basically, you pick a file name here for your local DB store, you tell it what entities you want in that store, and then you just call initialize. So now we know kind of local DB is ready to go, and then we'll just do a refresh. And when it comes to refresh, basically, it's the exact same programming model you're used to, the same programming model you would normally apply to the connected online table, the one that's just talking to the live service. So you can use link just the same way. And so all that just works exactly the same, even though you're now against an offline table. So this is basically refresh, right? So this is pulling down all the items. Let's show you an example of actually creating a new job. So in this case, this is when I filled in, a little request at the top and pressed add. You notice I instantiate an instance of this mobile job, and then I call insert async. And if you're a mobile services developer, again, this is the same model you're used to to work with online tables. The only part that is really different, other than initializing the database, is when you actually have to sync. So we have this sync context object, and off of it, there's a push async. So push tells it to basically send it to the server and let the server resolve any conflicts, if there are any. Then to download stuff from the server, we have these pull methods on the table. So you can pull from individual tables or pull from all of them like we do in this case. And there's very interesting things to handle here around conflict resolution. So if I update something and somebody on my team has deleted it in the meantime, who would win? If that happens, in this case here, these calls to push would actually fail, and it would throw a preconditioned failed exception. So that gives you the opportunity to handle that case and do the right thing. And I'm not going to go into details. I'm not going to show you how to implement this conflict resolution because we have a full talk tomorrow. I think it's around noon or 1 by Donna and Chris, and they're going to go into all the details of offline and show you how to implement conflict resolution client and server side. So all you need to know here is that you do have a way to catch these conflicts, and you do have a way to do the right thing. So with that, pretty much I think done with offline. So remember, we talked about data, and now we got to talk about auth and push. And for that, I'll invite Kirill back on.
Thanks, Yavor. So this is great. We now made our cable guy a little happier, right? Our cable guy can work with data, work with hierarchical data because the mobile services now uses this mapping extensibility using AutoMapper. Our cable guy is able to work with data in offline mode, storing data in offline. How many of you are actually interested in using offline framework? Well, quite a few, right? Yeah, offline is a very popular scenario. And I don't want to create any illusions. The offline framework, offline is also a very complex scenario. And the offline framework that we were showing to you, and you can get, and we'll show a lot more of it tomorrow, does not necessarily solve every possible offline scenario, every possible offline problem. It's lots of people, lots of very smart people spend their life in that problem space. What's specifically and interesting about the offline sync capability of mobile services is that it works on every client platform, And it works with a simple enough abstraction that allows you to layer it over any data backend, whether it's SQL, Azure Table Storage, Mongo, you name it. The other important part is that it does not only it allows you to store data locally, synchronize it, handle conflict resolutions, it also allows you to preserve the order of the operations. So you can handle a lot more complex scenarios with it because your operations on the local data, there is also a log over it. So we synchronize log as well as when you do push async. Third important aspect about offline is that there are, depending on the specific data backends that you're working with and specific client, there may be other frameworks out there that go into a further depth around offline, and you can use them with mobile services. Mobile services programming model on the server is Web API. So as long as the that particular offline framework, I'll call out an example of Breeze, for example, that's a JavaScript framework. You can use it with Web API. You can use it with mobile services. So pick the frameworks that works for you. We have a built-in capability that targets all the clients. If it doesn't work for you, you can use something else off the shelf. With that, we'll move to authentication. So cable guy is happy working with data. He doesn't know what data he's working with because he's not authenticated yet. So let's find a clicker. We added Azure Active Directory integration to mobile services. And that achieves two important goals. One of them is, obviously, you can log in now to a mobile service using Azure Active Directory credentials. So as long as your company has either an Office 365 account subscription, and whether it just has an Azure Active Directory tenant, or maybe it actually synchronizes it with a local Active Directory, you can use your Active Directory tenant, and you can authenticate with your Active Directory credentials with a mobile service. And I'll show you different flows around it. The second important part about integration with mobile services is that now we have this first-class primitive, which is the user in mobile services. We have the Active Directory user. And we can do many things with it. For example, we can enable turnkey send a push notification to an Active Directory user, or send a push notification to an Active Directory security group. So you don't have to maintain mappings. You don't have to deal with all these synchronization logic between your local mappings, between the physical device handlers and Active Directory users, etc. We can take care of it for you. So the integration of Active Directory with the rest of your mobile backend, those are type of places where mobile services make sense, where mobile services add value, because we can bring all these things together. And you can take advantage of them in your Web API code, no matter where that Web API code came from. So how does it work? Whenever you use Azure Active Directory, the 4 letters that you need to know is ADAL. How many of you have attended Vittorio session in the last couple of days? Some of you. So I'll spend a little bit of time on ADAL. ADAL, for the first time, Microsoft released an Active Directory client library for every platform that matters. And that Active Directory client library allows you to do single sign-on authentication with Azure Active Directory. And it does not require you to accomplish a PhD in Active Directory. It's relatively simple. So we're going to walk through some of the code. Now, Active Directory guys are doing a great job with this library. It's going to extend to even more platforms. You already have seen, even though it's Xamarin extension is not, Xamarin version is not quite yet available publicly. You saw it in the keynote, and it's a pretty simple sample using the bindings to native Active Directory libraries. So you'll see a lot more expansion in terms of platform support from the team. First flow is what you saw in the demo, in the keynote demo, and what our cable guy would love to get is basically a single sign-on using Azure Active Directory to a mobile service. The way it works is that client app, first, to accomplish this scenario, there are 2 important things that you need to do. You need to register your client application with Azure Active Directory, and you need to register your mobile service, your resource, with Active Directory. I'll quickly show you how we're doing on time. I'll quickly just give you a glance of what it looks like. So if we look back to our portal, and we'll look back to Active Directory, I have my Active Directory tenant right here, and I have applications. And you can see two applications, Field Engineer and Field Engineer Net. So one of them is the native client application that I registered with Active Directory. The second one is the mobile service. Back, you get the identification that allows you to actually use and register and get the right tokens from Active Directory. So if we flip back to the PowerPoint, once you authenticate to using Active Directory library, you get back a pair of tokens, access token and refresh token. Access token gives you access to a mobile service because Active Directory knows that you requested access to a mobile service. Refresh token allows you to refresh the token later on if access token expires, because we also want to make sure that the lifetime of the token is short enough to keep it secure. Finally, the client can pass the access token. Mobile services client understand Active Directory token. It can pass it to a mobile service, and in exchange, get a session token from mobile services that can be used for the continuance of the session. Once the mobile services token, once the access token expires, you get back 401, and you can handle that exception and ask the Active Directory to log in again. And under the covers, it will refresh the access token for you. You don't have to type in credentials all the time. Quickly, what does the code look like? So there's three important primitives that you need to know in order to authenticate with mobile services using Active Directory. It's the authority. In this case, this is the domain address of your login endpoint of your Active Directory tenant. That's the default one that you get with your tenant name in it. You also, so mine would be KirillG on Microsoft.com. You can override it and have a custom domain. Resource URI, that's the mobile services login endpoint that Active Directory, that you specified when you registered mobile service in your Active Directory. And finally, the client ID that you got when you registered your client application with Active Directory. Having these three settings that typically would not be hard-coded, but would be in the settings, you can call acquire token async. That will bring up the dialog if you haven't logged in yet, and get the access token back. And then you can pass the access token back to mobile services login methods that you already are familiar with and complete the authentication. Pretty straightforward, kind of two operations. Get the access token, pass it to mobile services. ADAL handles all the intricate of the state machine of the authentication for you, when to ask you for credentials, when not to ask you for credentials. All of that is already handled for you. Second scenario is what you saw in the keynote, where we want to access additional resources, for example, SharePoint, on behalf of the user. So our cable guy not only wants to authenticate to mobile services and get the data about the jobs and the history of the jobs, it wants to update, it wants to send the updates, and we want mobile service to store a document in a SharePoint containing a log of that history, of everything that was done on that particular cable installation. So it's very similar, except you have to do the flow twice now. You have to do the flow on the client, where you get an access token from Azure Active Directory. You send it to mobile service. Mobile service needs to be registered also as a client of Active Directory, as a client of SharePoint. So mobile service then takes the access token from the client, from the request, and requests additional pair of access token and refresh token from Azure Active Directory to be able to access the SharePoint on behalf of the user. And if I show you the code, it'll make more sense. So here's the user is in my request context. That's what I got from the client. This is the code that is running within the mobile services, within your web API method. I got the user. I can get the access token that was flown to me by the client, from the client when client authenticated to the mobile service. I can then use that access token and request additional pair of access token and refresh token from Active Directory by passing the SharePoint URL, in this case, my resource URL, as well as the assertion about the user that we want to access on behalf of. Right? So we want to access on behalf of our cable guy. And I get back a pair of tokens that will represent the rights. Active Directory will verify that that user indeed has access to the SharePoint, indeed is allowed to make updates. And then we get back credentials that allows our mobile service to access SharePoint on behalf of the user. So a simple delegation scenario used to be pretty hard to do. Now it gets much easier, and we have pretty good libraries. And you see that we have Active Directory library in the mobile service runtime as well, so you can use it within the mobile service as well as on the client, and you can achieve that on behalf flow. So to kind of these two flows are pretty important. So our cable guy got even happier. Now he actually can get his jobs. He can authenticate. He can get his jobs. He can make the updates. Those updates will be performed on his behalf. The authentication is taken care of. Now, one thing that many folks are annoyed by is that keep asking the app for updates. Like, what happened? Are there any updates around my jobs? As a cable guy, I'd rather have my device tell me when there are updates to my schedule instead of me keep poking and opening an app all the time. So push notifications is the way to do it in the mobile world. And we, as Ivor announced, we integrated notification hubs recently into mobile services. How many of you are familiar with notification hubs? Some. All right, so kind of quickly, notification hubs is a service that you can use to do cross-platform push notifications to any client from any backend, and we integrated it into a mobile service. What's happening in terms of the flow is that mobile service has built-in knowledge and creates a notification hub every time you create a mobile service. Mobile service gets the device handle, which identifies the device, and registers it with the notification hubs for a user. This way, you don't have to, when you're do push notifications with mobile services, you do not have to anymore to maintain the table of device handles. You do not have to maintain the mappings between the users and device handles. You don't have to maintain the mappings between interest groups and device handles. This is all taken care of for you by notification hubs. Every mobile service gets notification hubs included for free. You don't pay extra charge until pretty large number of pushes. And having that integration is another example how mobile services tie things together and make it easier for you. So now we can do this push-to-user capability, where we can actually send a push, using one call, send a push notification to an employee by virtue of knowing who that employee is, by virtue of knowing, having that device handle, appropriate device handle registered for that employee, and being able to use notification hubs to deliver that. There are many other capabilities that notification hub has, namely, it works with plethora of client platforms: iOS, Android, Windows, Kindle, Xamarin, PhoneGap. You don't have to deal with anything device-related around push. It's taken care of by notification hubs. It handles the feedback channels. It handles talking to individual platform notification services. It handles the mappings of the device handles. It works with logical. It lets you work with logical users that your mobile service knows about. It lets you work with allows you to localize and personalize the notifications, which is pretty important especially for consumer apps. And it allows you to do broadcast at scale. So you've mentioned, you've seen the Sochi example. Winter Olympics have sent hundreds of millions of push notifications using notification hubs. So the scale, it can do it at much, much higher scale than it would take a lot of time for someone to build custom such solutions themselves, because a lot of those things get harder as the scale grows. Obviously, it adds you rich telemetry. It's a huge improvement to mobile services push capability. and it's included in mobile services price already. So kind of bringing it all together, we have our field engineer application. If we switch, and run it, now we have a field engineer application that can ask me for my credentials from my Azure Active Directory tenant.
What will happen if you are offline now? You cannot reach.
Good question. So if you're offline, you can access your, you'll be able to continue accessing your local data. So it won't ask you, it won't prompt you. Now, once you're online, and either your app manually handles sync or automatically detects the network changes, then it will get 401 if the access token is expired, and it will prompt you. Right. So you have to do a little bit of code there. Basically, you have to plug in, and we have it in a tutorial, you have to plug in a request handler that does this checking and renewing of the access token. But otherwise, you don't have to do it in your application code. You just plug it in a mobile service client. So we'll do it.
Let's take the detailed questions at the end. We have a little bit of time for Q&A because we just have 1 minute left.
All right, so I'm able to authenticate, and now I'm logged in. Great. And now the app knows who I am. I get my jobs, and now I can browse them. I can work offline with the data. I can be able to sync. If a new job for some reason or some updates that I really need to know about arises, maybe I'm gonna get even push notification. So great. With that, since sounds like I have a pretty rough directive, we can switch back to our slides. Just to highlight the key points, what did we show today? One important announcement is everything that you've seen today, the mobile services.NET runtime will be open sourced. You can take it, and that's a key promise of mobile services, that there is no lock-in. If you try it out, if you don't like it, you can take the entire solution, the code, the mobile services runtime, you can take it, you can run it on a VM anywhere you like it. It's all open source. You're welcome to contribute. We'd love contributions. Makes our life easier too. Why mobile services.NET backend? What role mobile services play? It's a backend for your app that you can get in seconds. It's very easy to create. It's very easy to maintain. Your backend logic is built using your API familiar to you. If you are a web API developer, this is a great place for you to host your web API if they're mobile facing, because you get a bunch of turnkey mobile backend capabilities built in. So you have another place to run your web API and use those mobile backend capabilities. If you're a mobile developer, web API is a very powerful framework for you to extend your mobile backend that you got in seconds with your custom logic. And it's pretty powerful. You can get a bunch of turnkey capabilities that we talked about, working with data securely, offline, Azure Active Directory, push notifications, you name it. You get client SDKs for all the platforms, including both native platforms as well as cross-platform frameworks like Xamarin, PhoneGap, Sencha. You get integration with on-premise systems using Service Bus Relay, as well as integration with Office 365, as we've seen in the keynote. And finally, we know so much about the runtime and the code that is running that we can give you much higher service for it. We can manage it, run and monitor for you, and we can tell you when something goes wrong. With that, thank you for your time, and we welcome any questions.
Yeah, thank you very much.